Ciao friends! In this video we will talk about natural left outer join and natural inner join. Yes, DAX has two functions that resemble the join functions we have also in SQL, the query language. But these functions work in a different way. So we wanted to show several examples of how these functions can be used, how they work. We actually will do another article in the future to also explain how to use these functions in a more advanced but practical way in your code. The goal for this video is to understand how these two functions work. This name is very long. Is similar to what we are used to see in SQL, if you know SQL, but is actually different in the way that it is always implicit how to specify the join condition. The join condition is always made by two or more identical columns in two different tables or in columns that are connected by relationships in the model. So we're going to see several examples. Let's start with the demo. So let's start looking at the join functions in DAX. We will start with a simple model with just two tables and a relationship, and then we will see what happens when we have different situations with or without the relationships, and also what happens with variables we have in memory. So let's start with this simple example where in this model we have two tables, product and subcategories, and you see that the product and subcategories tables are connected by a relationship that uses the subcategory code to connect the two tables. Now, usually we don't need the join functions in DAX. We just use the columns that we are interested to, and functions like summarize columns do the job for us of joining the tables. But what if we want to get the same result we would obtain in SQL by joining the two tables? So if we go to the DAX query view, we can actually look at the content of the tables and write DAX code looking at the result of table functions. And the syntax to do that is, for example, let's see the content of the product table. So we say, well, I want to see the content of the product table, evaluate product, I click run, and I see the content of the table. This table should have subcategory code column somewhere. The order is just not the same that we have seen before, but this is the column I want to highlight. Let's see if I can enlarge this a little bit. So 0702 is the combination of category and subcategory that is used in the subcategory code column. Let's take a look at the subcategories table, this one. So I click run, and you see that the number we have seen before is now also the number available here. Now these two numbers, these two codes are in two different columns in two different tables, but because they are part of the same relationship, they can be used in a join function. How can we write a join function? Well, we have two functions, natural inner join and natural left outer join. Let's start with the left outer join. So with the left outer join, I can specify two tables, the table on the left, the table on the right of the join. So the table on the left will be returned including all the rows. So all the rows of, for example, the product table. We want to include all the rows of the product table, and for each row of the product table, we want to combine the corresponding rows in the subcategory table. Now, if you think for a moment, the relationship we have, let's go back to the diagram view, we have a one-to-many relationship between subcategories and product. Now, if I start from the product table, it means that I will get all the rows of this product table, including those rows that might have non-existing subcategory code, and I will see the corresponding value of the subcategories table. So I don't expect to see additional rows, but I might have blank rows for the subcategory columns in the result of the left outer join, because the left outer join includes all the rows of the table on the left and only the corresponding rows of the table on the right. Because we know that the subcategory is on the one side of the relationship, we don't expect an additional number of rows. For each product, there could be only one subcategory. So we don't expect to have additional rows. So let's try. So if I go back to the DAX query view and I write subcategories, and I close the parentheses and I click run, I see the result. Now, of course, the result has many columns, so we can see that there are cases where the the subcategory is blank, but if I scroll down, the subcategory is actually populated with something. Now, because having all these columns is a little bit hard to see, we can simply reduce the number of columns by including a select columns function. So I want to use the result of the natural left outer join, but I want to only display 2 columns. So I can display, for example, the product name, and I want to display, let's say, the subcategory column. That's it. So just the name of the product, the corresponding subcategory name. Run, and it just works. Now, for those of you that come from a SQL background, both executions are relatively strange because I didn't specify how to implement the join condition. If you come from a SQL background, you're used to write in the query an explicit condition that says, I want to join on this column. Now, the information about which condition joins the 2 tables is obtained by this relationship. So we don't specify in an explicit way what is the join condition. In this case, the join condition comes from the data model. Now, what we obtain at this point, if you think for a moment, is we wanted to see all the rows in the product table and the corresponding columns in the subcategory table. But if I want to obtain the same result that I wrote here, actually I just obtained the product name and the subcategory, the corresponding subcategory name. So instead of writing the code this way, I could write, and let me write in the same query, evaluate of what? Well, the DAX way to write this to obtain the same result is, for example, by using select columns, because we want to get all the rows of the product table, and for each row of the product table, we just want to get the product name column from the product table and the subcategory column in the subcategories table, because we have to traverse a relationship many to one. We use related subcategory. And if I use the code this way, now you see that I have 2 evaluate statements, this one and the second one. So if I execute this code, I obtain 2 results. The error you see here is not an error, it's just a bug of the editor that doesn't recognize this as a valid syntax, but it is actually a valid syntax. I hope that it will be fixed later. But at the moment we have now 2 results, 1 and 2, and they are identical. You see that when I switch from 1 and 2, nothing changes because I can obtain actually the same result with different techniques. Select columns is like a projection that we do in DAX, so like the select statement in SQL. We could have used another function like summarize. So I can write evaluate summarize. In this case, I want to use summarize for the product table. And for the product table, I want to group by product, and I want to include in a group the product name. So the product name from the product table and the subcategories subcategory column. Again, because we have a many-to-one relationship between product and subcategory, in the group by condition, we can include both columns that are also in 2 different tables that are in a expanded table starting from product, following all the many-to-one relationships. So this is just to, and of course, if I click run, now I have 3 results, 1, 2, and 3. They are completely identical, no differences, they have the same content. So why should we use the join? Well, the use case for the join is actually limited in DAX, but the goal that we have in this video is to understand how it works. The reasons why we might want to use the join is actually when we have a situation where we actually want to manipulate the tables, maybe temporary tables we have without relationship, like in this case. And at that point, also for performance reasons, this could be that could work better than other approaches. For these kind of simple calculations, of course, this is not necessary. As we have seen, we have other techniques we commonly use in DAX. We don't need the join. Now, we So let me remove these other two examples and let's go back to this natural left outer join we use for between product and categories. If I execute this code again, you see that we are including all the products that have subcategories or not. So these are products without subcategory because the subcategory code doesn't exist in the subcategories table for some reason. And the other are products that have a subcategory. But we always keep all the products because we have a left join. If instead of using the left join, we use a natural inner join, then like in SQL, we will see only those rows where there is a corresponding subcategory for each product. So now we have a result that has 2517 rows. When I'm going to execute this code, I expect a smaller number, only 2305. So there are several products that don't have a matching subcategory. And if we scroll down, we no longer see any blank value in the subcategory column. So this is the difference between the left join and the inner join. Now question, what if we wanted to do this in DAX without using the join function? Well, we can rewrite this code in DAX by using, for example, generate. So if I evaluate, let's say that I want to evaluate, the help doesn't help much because I want to have space to show the code. I want to use the generate function. And for each subcategory, I want to generate the existing products for each category. What happens is that I will only include the subcategories that have products. And if a product doesn't have a subcategory, it will not be displayed. If a subcategory doesn't have product, it will not be displayed too because I'm using generate. If I use generate all, then it's like saying I want to see all the subcategories and then add the category. But sorry, the products. But if I write generate and I say for each subcategory, I want to get the related table of the product. Again, this is something I can do when I have a relationship in DAX. But if I write the code this way and I run this code, I get in the second result all the columns and only those rows, 2305, that correspond to what I want. Now again, I don't want to see all the columns, I want to see only two columns, so I can just copy the same select column statement that I used before. So I want to just use these two columns. And now when I click run, I'm still executing both queries. And so the result 1 is now identical to the result 2. The order could be different. So we have to add an order by if we want to make sure that the order is predictable. So let's use the same order by in both because I want to demonstrate that if I run this query, the result 1 and the result 2 are completely identical. So we don't have to use a join function to obtain these results. In DAX, we have alternatives. So join is not necessary when we have relationship and a simple scenario like this one, even though it's another tool we have available that we will see is better, is more interesting in other more advanced cases. But at the moment, we just want to understand how it works. In this second example, we see what happens when we have three tables with a one-to-many cascading relationship. So in this example, we use categories, subcategories, and sales. Now, sales is a special table that has only one row for each subcategory code and each year. The goal we want to create a single table where we have for each category, all the subcategories, including those categories without subcategories. And for each of these rows, we also want to see the value, the sales amount for every year. So basically, we want to expand all the three tables together and obtain the result. So we go to the DAX query view. We can create a new query, for example, and we start writing an evaluate statement. This time, instead of starting from the many side of the relationship, I want to start on the one side of the relationship, the category table. So I write my evaluate categories. Let's start from this. If I click run, I see all the categories. And my first step, I want to join in a natural left outer join the categories table with the subcategories table. IntelliSense doesn't help me too much today, but here we go. So if I complete this task and I click run, now I have all the categories, all the subcategories. If I scroll down, you should see that I have also this games and toys category that doesn't have any subcategory. And my requirement was I want to see this, line. And so for this reason, I wanted to start from the categories table, not from the many side of the relationships. But I still have to include the sales table. Before doing that, let me just order this result by category code and by subcategory code. This is important because when we want to actually see the result, we want a predictable order. So this way it helps me to quickly locate, for example, this one, games and toys 07, I think is the only category that doesn't have any subcategory, okay? We want to move forward. We want to add to this join also the sales subtable. So we add natural left outer join. And natural left outer join only has two tables, so we have to use nested function to join 3 or more tables. And at this point, I use here sales sub, and I can click run. At this stage, I see many more columns because we also have the value of the year and the value of the amount. And you see that we start to see something different because now we have let's take a look at this. For the audio, so this one is audio Bluetooth headphones. So this one is 0106. If I go on the right, you see that I have no sales for this subcategory. So we have the category, we have the subcategory, we have no sales and no years. So again, we have another blank here now that appears because of that. So keep in mind, and let me sort also by sales sub, let's say year, and in case we have the same year twice by amount, just in case. It shouldn't happen, but in case we have a problem in data quality, that could help understanding the result. Now, if I run this query again, it should be identical to what we have seen before, and I want to focus on the two blank rows we have. So we have one blank row here, Bluetooth headphones. So we have a subcategory without sales. We have another subcategory without sales, 0308. And if I scroll down, we have a category without subcategories. So remember, we have 3 blanks. 2 of them have a subcategory. 1 of them have no subcategory. Okay, all the 3 ones don't have sales, of course, but the difference is this table in the middle. Why am I showing this? Because we are used to think that we always have to include all the joins conditions, all the tables in the joins. But because we have a data model on the back, we don't have to specify everything. We are not specifying the join conditions. If our goal is to show the value for each category, we want to see the sale for every year, for every subcategory code, we could skip the subcategories table. So what happens if I, for example, just join the categories table with the sales sub table this way? Of course, I cannot use this column anymore. I will use sales sub subcategory code. But if you remember the data model, let's go back to the data model. Now I'm getting the subcategory, the category table and 1 column from the categories table, and we get 3 columns from the sales sub table. We're not saying we have subcategories involved. We're not saying we have these 2 relationships involved. It doesn't matter. If I click run, the model knows that the only way to provide this result is to navigate through the relationships and obtain a corresponding join. So it's completely automatic. When you write join, natural left outer join, you might involve more tables than those that you explicitly declared in the function if you're using model tables with relationships, which is our use case. But in this case, there is a difference because we only included categories and sales sub. Now, if we take a look at the result, we see that we have only this row, games and toys, that has blank subcategory. If you remember, we had two subcategories that didn't have any sale. Now, we no longer see these other two rows here. These two rows disappear because we didn't provide any information to include those rows, because the row doesn't have, is like we don't have an actual content to display for these two cases. And so this is a difference we have compared to the other case where we included the three tables. So this is already a difference we have. Actually, this is not the way many people are used to think when you use a SQL. I've shown you that this way of writing a join is similar to a generate function in DAX, which is similar to a cross-apply in SQL, to be honest. So it's not actually a join, but this is the way it works. So when we go one-to-many, we do something that is a little bit unconventional, I would say. But the way we are used to see this is actually the opposite. We usually see in SQL, we start from the many side and we go to the one side. So if I invert the two parameters and now I get all the transactions and I want to see the categories, then what happens? At this point, I'm including transactions that that don't have any subcategory and that don't have any category. But those transactions will be included in a single blank row. So if I click run, you see that these transactions are all displayed here. And because I'm including in the result the subcategory code, I'm not summarizing, I'm just including the value, all the columns of the table sales sub. I see the sales for these years for a subcategory that is blank. Then we have 0104, 0201, and all these subcategories don't have a matching category because we don't have these categories defined in the category table that we're using. We intentionally created tables that don't have these values. So this is an important difference because at this point, if I scroll down, I no longer see that row that we have seen before when I used the other technique. So if you remember, there is a category that doesn't have any subcategory. Because I'm starting now from the subcategory, I only see categories for which a subcategory exists, and I see blank for those that don't have a name. But if I don't have sales for a particular category, the category is no longer visible here. So this is the way it works when we do the calculation this way. Now, this is not the way we are used to write this code in DAX again, right? So if we want to obtain this join, so starting from the many side, going to the one side, what's the technique we use in DAX? Well, we usually use evaluate with summarize or summarize columns, but let's use summarize, which is simpler. And in summarize, I want to use the sales sub as the reference, expand the table that we group by. So we group the sales table by the column that we want to include in the visualization. So we want to include the categories, category column, the category code column. Then we want to include the sales sub. Actually, I want all of them. So I want to see the subcategory code. I want to see the year. I want to see the amount. And that's it for summarize. And of course, I can just copy and paste the same order by. And so this summarize will produce the same result we have seen before. So now I have two evaluate statements. I run the two of them. Result 1, result 2, identical result. So once again, we have seen that by using summarize, we can obtain the same result we can obtain by using the natural left outer join. Of course, this is just another example. The main takeaway in this case is that if we look at the data model, we see that we don't have to specify the intermediate tables. The important thing is that we combine tables that have regular relationships connecting them. Remember the left join and the inner join in DAX can only consume regular one-to-many relationships or one-to-one relationships. they cannot work with many-to-many cardinality relationship because those relationships are not regular relationships. They are not recognized by these join functions. But there is more in a moment. Yes, when we have relationships in the model, all is good. The join functions automatically get them. But what happens if we don't have relationships? This is the case for two different situations, two different scenarios. First, we might have tables that have no relationships in the model. Second, we might have variables that have data in a table format. When these columns don't have a data lineage, how can we join them without the data lineage? So actually part of that will be the topic for another video, how to join tables in the model that don't have a relationship. But even though we don't cover that part in this video, I want to show you what happens, because starting from that point, we can explain how to combine variables that contain tables. So let's start from this. So let's take a look at these two tables. These are just different versions. In particular, products with the S, with the final S, is a table that doesn't have any relationship with the subcategories table. So you see that these two tables exist in the model. They both have a subcategory code column, but what happens if you try to join them? So let's take a look. If I go in the query view, let's create a new query. If I write evaluate, let's say products with the S. So if I run this query, I see all the products. If I type another evaluate and I write subcategories, I can see all the subcategories. This is the second result we have here. What if I combine them? So if I write evaluate NATURALLEFTOUTERJOIN products, comma, subcategories, if I try to run this query, so let's go to a new line and run, I have an error. And the error says no common join columns detected. The join function requires at least one common join column. So what is a common join column? In DAX, it's a column that belongs to a relationship in the model. Like in this case, subcategory code and subcategory code can be used because we have a relationship. But whenever you have two tables in the model, what happens is that, well, if you think for a moment, let's go back to the evaluate products and evaluate subcategories. Let's take a look at the content of these two tables, because this will teach us something. When you look at the result, the name of the column is actually the entire name, products subcategory code. Products, table name, subcategory code, column name. Now, if you look at this column, this name is different from this other one. This one. Why? Because yes, we have the same column name, this part, but we have a different table name. So even though the two columns have the same content and the same column name, because they have different table names, they are actually different columns. So a column name is the entire fully qualified name, table name, column name. And if these two names are different, the join doesn't work unless you have a relationship. So the relationship is the exception that connects two different columns together. But if in a variable I have the same column, then it will be used as a join condition. So we cannot actually solve this problem yet here. This is the topic, what to do when we have tables in the model. Well, we have to break the data lineage. We have to change this name so that it is the same, and at that point we can do something. We can see how this works with the variables when the variable doesn't have content obtained from the model. So let's say that the variable is the result of an expression, an aggregation, or something that you create with this static content. In this case, we have in products, we have just 3 rows with a product name and a category, a subcategory code. And in subcategories, we have a subcategory name and a subcategory code. So if you look at let me comment these other statements I prepared. So let's evaluate just products and subcategories. So in this case, products and subcategory with the underscore are just variables that contain 2 tables created on the fly as query tables. So if I run this code, I see that the content of the products variable and the subcategories variable is the following. So the same content we have seen in the code, nothing different. Now at this point you can notice that the result 1 has subcategory code, no table name, and result 2, same string, no table name. No table name because we didn't include a table name. We could have wrote this code by writing something different, like for example ABC table name, and that's just a name, right? So the name is just a string. The fact that it is composed by a table name and then a column name is just a detail. At the end, we look at the engine, look at the complete name. Now, because these two columns have the same identical name, that name will be used as a join condition. If we write this first code, natural left outer join from products on the left, I want to see for each product the corresponding rows in the subcategories table. If I run this code, what I see is that I have for each product, so we have 3 products, black, blue, and silver. So I'm doing a join, a left join between these 3 products and the content of this table. Now, if we take a look at this, we have 0308, 0308, 0803. In the subcategories table, we don't have 0803. So we expect a blank for the last row of the result of this join. Indeed, we have a description for 0308. We don't have a description for 0803. Please also notice that my join column is present only once. If you remember, when we joined 2 tables with a relationship, we had both columns on both ends of the relationship. Basically, you had the same subcategory code twice. Now we have only once. We have subcategory code only once because it is the same column and it has to be present. In this case, as a left join, it's always present from the left side, but the one on the right side is ignored. There is no need because we have something else, like for example, in this case, the subcategory blank value. What happens if we do the opposite? So we start from the subcategories, and for each subcategory, show me all the products. At this point, I can run this code again, and so the result number 4 is the one of the code that I uncommented now. So we have for each subcategory all the products. So for the subcategory 0308, we have 2 products, 1 and 2. But for the second subcategory 0401, we have no products. So the number of rows we obtain depends on the number of products, but we always keep the rows of each category, each subcategory that exists. If we had products that don't have an existing subcategory, they are not displayed. This is the way the left join is supposed to work. And what happens if we use an inner join? Well, if we use an inner join, what happens is that we only see the 2 rows that have a match. This row will disappear. So I expect in the 5th result to see only 2 rows without the digital cameras. If I run this code and I go to the 5th result, you see only 2 rows with just the subcategories that have at least 1 product, which is indeed the way the code works in this case. But we might have the need of joining 2 tables by using 2 or more columns. Now, when we have a relationship, this cannot happen because a relationship by definition exists only by using 1 column of the model. But when we use this other technique of joining 2 tables by matching the column that has the same name, well, actually, all the columns that have the same name will participate to the join condition, which means that we might have a more complex way to create the join just by specifying multiple columns with the same name. So I prepared a last example where we have 2 variables. In this case, we have products where we have the category code and the subcategory code in 2 different columns. Before we had the subcategory code was including actually the category and the subcategory in a single string. Now we have these two values in two different columns, like 02, 03 are two different columns. And same for subcategories. Subcategories has the category code and the subcategory code with the description of the category and the subcategory. So let's start this code. So let's comment these three examples, and let's repeat the same example we made before. The content of the products and subcategories table is visible now table by table. These are the 6 products we have and the 5 subcategories, categories and subcategories we have. If I uncomment this, where I join for each product, I want to see the corresponding subcategories. I expect 6 rows in the result. Actually, I have to get this one, okay? I expect 6 rows in the result number 3, just like the number of products, but I have the category and subcategory. How this is working? You see that category is 02 for this case and this case, so we need both the category and the subcategory, and just the subcategory will not be enough because we also have 0803. So you see that we intentionally chose a few values that will not work if we only used one column. So the join is actually using the 2 columns, category code and subcategory code, that are visible only once in the result, but are used to join the 2 tables. And you see that for this particular product, 0308 is a combination that we don't have in the subcategories table. Now, what happens if we do the opposite? So we do a left join where we use subcategories and then we go to products. Then in this case, we obtain the list of all the subcategories that we listed. So the result number 2 is the list of all the subcategories. We have 02, 1, 2, 3, 8, 1, 3, 6. So if I go in result 4, I see the same combinations, but I also see that we have 2 products. These 2 products here have the same combination of category and subcategory. So the number of rows increases when we have multiple products for the same subcategory, which is this case. So this is the reason why we have 6 results. But in this case, look at the 6th row. In this case, the 6th row has a combination of category and subcategory that is a row in the subcategories table that doesn't have any product. At the same time, if you remember, we have seen a product, this one, Contoso Bright Light Battery. This product is not displayed when we do the join from subcategories to products because we only consider all the existing subcategories without the need of having a product. But if a product doesn't have a corresponding subcategory, it is not visible here. So the last one is, of course, the inner join will just hide this blank row. So if I execute this last version, I see that in the result number 5, we have only 5 rows. If we compare result number 4, which is this join, subcategories products, with the inner join, so we compare the left outer join with the inner join, we simply don't have the blank product because we only show the combination that have at least 1 row on both sides of the relationship. Time to sum up what we have seen. So we have seen that the natural left outer join and natural inner join can produce a result that is similar to what we can do also in SQL with join functions. The difference is that in DAX these functions are not necessary. We have seen several techniques where we can combine the content of different tables for a result in DAX obtained with different functions. So 90% of the times you don't need these functions. However, if for any reason you actually have to combine different tables, getting a table as a result, not just the result of a grouping function like what we do in summarize, not just the propagation of a many-to-one relation like we do with related, then in that case there are side cases where this function can be useful. Sometimes they are also good because they could combine different variables with performance that is much faster than using other approaches based on filter and cross-join and predicates that compare the content of the result of a cross-join. So as a way to optimize the code, when you combine different tables, it could be useful, but at that point, it probably requires a more complex scenario than what we have seen today. The goal for this video was just to explain how these functions work. In a future article, we will see something more advanced, how to use this function in a more advanced way, especially when you don't have relationships and you want to connect different tables together. Enjoy DAX!